Kate, do you want to hit the, thank you. Good afternoon, everybody. My name is Martin Berry, and I am the chair of the Pipeline Industry Guild's technical panel for outfalls, intakes, and landfills. And it's with great pleasure today that we are able to give you and present this webinar by the Water Services Group and Paul Hope Darby. And he's going to be talking about pipeline solutions and different types of really complicated and technical piece of equipment they use to undertake inspections of various pipelines and challenging locations. Paul himself was a saturation diver in the oil industry, which he stopped around the 80s to set up the company and look at both pipe and tunnel inspections. And Paul heads up the Water Services Group, who have a history of undertaking work, certainly in the UK water industry, back to AMP1. I've worked with Paul previously as well on inspections of marine outfalls, and I know he was also doing a lot of work with inspections of the Haweswater Aqueduct and various other projects in the Northwest region. So great pleasure to hand over the webinar to Paul. As I say, anybody's got any questions, please post them in the chat. Over to you, Paul.
Okay, hi. Thanks very much indeed for the opportunity, Martin. I've got Glenn Webber, who is accompanying me and will be assisting with some of the explanations. I'd like to thank all three of you for attending, four if you include Martin. And basically, we inspect pipes, tunnels, aqueducts, all sorts, and have been doing for a great number of years now. The title of the seminar really was the challenges associated with it. We've been doing this since the 1980s, when we used to put divers up pipes with cameras, and they would do a limited survey for as far as the diameter and the nerve would hold out. The HSE at about that time started to have an interest in keeping divers out of pipes. So we were being approached by the water authorities with a view to carrying out this type of survey remotely. So with the development in mind, we approached both marine and ROV engineers who at the time said that what we were trying to achieve couldn't be done. We were unconvinced by this, so we set about creating our own systems and building them from scratch. We succeeded with this, and initially we built a fully surface controlled unit with an excursion range of 1 kilometre. As always, we've been driven by our clients' expectations and requirements, and every day pretty well has been a development day, and this continues to this morning. Hence the lack of time to prepare for this. But the early challenges, basically, there was no proprietary equipment available at all. The underwater connectors couldn't be sourced, the control systems, the batteries, everything had to be invented, designed. A lot of the stuff in the very early days was just modified to get the job done. But eventually we started to make progress in the control systems. The ongoing challenges always are access difficulties. We're working either from very deep, narrow, restricted shafts with obstacles, platforms in the way, restricted access. We're trying to get a 2-pint machine into a 1/2-pint access hatch. We've developed techniques for getting into pressurized pipes on remote locations. This morning's challenge was trying to get our gear through the customs at Saudi, which is nowhere near it. There's been an ongoing demand for increasingly technical inventions, extreme flow rates we have to deal with. We've surveyed up to, in a cooling pipe for, I think it was Alcan, up in Tyneside, we had to deal with a 6-metre flow rate, and the whole control system had to be designed specifically for that, because thrusters don't work in fast-flowing water. A lot of the things we're dealing routinely with are intermittent pumping schedules, no isolation available, poor water clarity, harsh environments with the sewer pipes, the outfalls, and conversely, we're having to deal with the challenges associated with putting systems in potable water, the hygiene standards, the nature of the materials going in, their shelf life, and what they will do if exposed to extended duration in potable water. This particular project was one of our multi-camera systems. We were contacted at very short notice to inspect a 21-kilometre long by 2.5 metre diameter for the Environment Agency. The challenge was made all the more difficult by 90-metre water-filled deep shafts accessed via very narrow hatches, you can see, just below the launch frame and the ROV cage. There's an access hatch which is about 50 mil diameter larger than the dimensions of the machine that had to go down there. So this system had to be driven down 90 metres and then driven along the 2.5 metre diameter tunnel for up to 7.5 kilometres in one particular section, as the longest run was 14 kilometres between hatches. So basically we had a profiling sonar system on this, multiple cameras, so the whole of the pipe could be viewed. And this was the view from inside the pipe. So the client was able to detect hairline cracks, any change of shape, any deformation on the profiling sonar. And on this particular tunnel, 21-kilometre tunnel, the last 4 or 5 kilometres did have a slight flattening effect of about 45 mil. So the client was able to see all the information they needed and accurately measure the profile. This particular example here is a project we carried out at Copper Mill's potable water tunnel at the treatment works. We had to survey 2.7 kilometres of 2 metre diameter live potable pipe, potable water, in a potable water pipe rather. What you're seeing here is a system that is about to be launched into a water-filled launch pod. So the pipe inspection vehicle in the background had the hydroplanic control system, because the thrusters, as I mentioned earlier, don't work well in fast-flowing water. So with a flow rate of about 0.8 to 1.2 meters a second, we had to use a different technology. So this is the machine being prepped prior to going into the launch chamber. And this is the machine in the chamber with the sealed hatch launched. The cable is passing through a cable gland. The frame was then lowered 20 meters down a shaft, turned through 45 degrees. The pipe inspection vehicle was launched into the pipe, and the cable and the launch frame acted as a cable guide. So we then surveyed the distance, recovered it back into the launch pod, depressurized it and recovered. This is one of the jobs that we were doing for Martin when he was with UU. I think this was the Haweswater Aqueduct. We had to design and build an autonomous PIV that could gain access to about a 2 meter diameter tunnel through a very restricted access. So what you're seeing there is 8 extending arms with a camera and pan and tilt mounted on each one. It was folded forward to get it through the access hatch, and then once in the pipe, it all had to be expanded, the camera positions adjusted, and then once everything was set up, we'd send it on its way and recover it about 20 kilometers further down at the next access hatch. All the data was stored on board, and then the client was given a caddy and a viewing system so they could view the whole of the 8 cameras. Going to the other end of the scale, the smaller extreme, this was a 3 kilometre, 200 mil diameter pipe that supplied potable water from the mainland to the Isle of Wight, and it was compromised when a ship's engine failed and its anchor dragged over it and split it. So this system was designed and built within a month. You can see the small pipe inspection vehicle there in the launch pod. That's the launch pod sealed, cable gland housing the cable, and that was pressurized to 15 bar. So in that picture, the machine is now traveling down the pipe. We found the point of the burst, measured precisely. They were then able to recover it to the surface and carry out a surface repair prior to repositioning the pipe. Yet another challenging one. This was for Edf France, and the site was at the top of the French Pyrenees. They were having a big problem with bulk water leaking from the pipe. And the problem, as you're aware, a lot of the pipe leak detection systems work on a high pressure, but very small leak. So it gives a particularly high pitched signal. In this particular case, they had high volume at low pressure. So working with Edf in France, we developed a hydrophone system that would work in conjunction with the pipe inspection vehicle. And we had a dye dispersant system, which would enable us to actually inject dye and follow the route of the water coming out of the pipe. In actual fact, we found the largest leak when the machine got drawn into it, and it took 2.5 hours to recover. But the project was successful, and we recovered the ROV, which is always good. That's the system being launched down this large access tunnel. So we had to get about 2.5 tons of equipment to the top of a particular mountain range in the French Pyrenees. We then had to lower this system 40 meters down a shaft, and round about 2 or 3 meters below water level, there was an access hatch, which was barely larger than the pipe inspection vehicle, which we had to negotiate in order to get into the pipe. Yet another system. This is designed for profiling sonar, non-destructive testing. We had to build this for a particular job in Killala, Western Ireland, where the machine had to be launched into a 900mm pipe via a 90-degree bend. So this system was articulating, it bent in the middle, it was able to negotiate the bend and then traverse the distance. We were pinpointing, which we found out subsequently, we were pinpointing holes where the joints had separated. We had high silt and debris accumulation where it was entering the pipe through the holes, and we were then measuring wall thickness on key sections of the pipe. I think on the same project, we're also doing water sampling and silt sampling. I'll hand you over to Glenn. This was one of his key projects.
Yeah, this was a client of ours was recommissioning a water main. Originally, the water main was concrete construction, but it had been lined with a GRP liner. Between the GRP liner and the concrete host pipe had been grouted, but not grouted well enough, and that was causing the liner to burst in sections. So our client commissioned us to design and build a manipulator that would carry a radar head, and the radar head was carried by the crawler through the water main, taking longitudinal scans of the main to identify, locate and measure voids between the liner and the host pipe. Now, I'm not going to labour on too much about the detail of this diagram, but I will say we needed to get the accuracy and the location accuracy of these voids or anomalies to within plus or minus 10 mil, which we did achieve with the help of a consultant who analysed the data for us. We have for a while now used LiDAR to plot, georeference and map assets by producing 3D point cloud models accurate to tenths of millimeters. What you can see on the screen at the moment is a 2D model of an underground asset overlaid on a map of the surrounding area. The main application for this was for new developers who wanted to put piles and or foundations for new builds into the ground. And this can allow them to put them in the right place without damaging or impeding an existing asset. This is a personal favourite of mine, this picture. It's a very early iteration of a waterproof housing for the LiDAR that we attached to the crawler unit. It's, yeah, really like that one. The accuracy of the LiDAR scans allows us to check for ovality of an asset, pinch points within an asset and obstructions. This application really helps us to allow a client to plan and design things like liners to go through pipes. This picture here shows a hydrant outtake from a water main. This 3D model, the picture doesn't show it very well, but the 3D model can be manipulated in such a way that measurements can be extracted, so we know exactly how big those obstructions are within the pipe. The same client also asked us to measure the displacement of sections of their pipes. There's a segmental asset, that the liners, and this was so that if they were forced into putting a secondary liner in, they could tell how tight a turn the liner was going to take. And again, from the LiDAR model, these measurements could be millimeter perfect.
Okay, so as you've probably gathered by now, we find ourselves in all sorts of situations where surveys have been carried out on assets where no previous knowledge is existing, particularly in some of the old chalk adits. We've gone in there and we've found old bogey tracks, the miners' lamps where they've had to they've been excavating, they've had to get out in a hurry. So on a lot of these assets, where we're travelling 2,000–3,000 metres or more, what we find is that when it comes to providing a repair solution, a lot of the normal suppliers aren't able to. In this particular case, we had to design and develop a pipe and tunnel cleaning system, because this particular asset was 600 metres long, at least 40% full of silt throughout. There was access at one end only. So we designed and built a pipe and tunnel cleaning system that is primarily designed for long distances. It can be used in water-filled pipes, live pipes, but it will function in situations where none of the conventional cleaning systems will work. So this was a particular project for Thames Water through Barhow, where we did an initial PIV survey to determine the silt levels. Once we knew the volume of silt, we designed and built the system to completely remove the silt, as you can see in the right-hand picture, prior to the Thames Water engineers doing a walkthrough survey. On another cleaning project down at Hooksey Outfall, we had to carry out cleaning works from the shoreward end. This is showing a large vacuum and jetting tanker set up on a barge at the seaward end of the outfall. In the far distance, there's a dive spread and the pipe inspection vehicle control centre. So we were going in there, we carried out an initial survey. We then, as a cleaning operation, removed the blisters formed, tuberculation blisters. So we removed those. Then we carried out a survey. We carried out non-destructive testing all from inside the pipe, and then we jetted the remaining sections clean. So that's the offshore end of it. This is the inshore end with a portable jetting unit mounted on an all-terrain vehicle. Another specialised project, a particular client was unable to drain down their reservoir, but they needed to reline the outlet pipe. So we designed a system that enabled the pipe to be relined live without any water loss and without any requirement to either shut down or drain down the reservoir. This is a pipe inspection system that we designed. Sorry, not a pipe inspection, a shaft inspection system designed for a potable water shaft down on the south coast. So using this system, which was fitted with inclinometers, flux gate compass, cameras, lights and profiling sonar, we're able to determine the verticality of the shaft, the condition of it, the orientation of the adits running off the bottom. And then we designed a system You can see in the right-hand picture where we've removed all of the old timber that was supporting the top half of the shaft. We then installed stainless steel mesh, rolled stainless steel supporting brackets, expanded out on bottle clamps. So it was a complete reline and rebuild to stabilise the shaft. We then subsequently surveyed all of the adits with CCTV and profiling sonar. This particular job, this is a method that we designed for sealing off and decommissioning live draw-off pipes where the conditions prevented the reservoir from being drained down, and the SSO had put a water leakage ban on anything coming out of the downstream end. So without any water loss, we inspected the system, assessed the condition, and then designed a system whereby the whole of the draw-off pipe could be filled with a structural grade concrete. On a more recent project, this started off as a 4-man diving team that were going to spend 4 or 5 days just decommissioning a swing bridge. It ended up requiring 3 7-man teams working overtime 7 days a week. And on this project, the structure you see there is the steelwork that was underwater, supported the swing bridge. And we carried out a combination of thermic lance cutting, welding, and I think we removed about 80,000 tonnes of ballast. So this eventually turned out to be the largest civil engineering diving project running in the UK at the time. This is the means of getting any equipment to any location, an amphibious all-terrain tracked vehicle. It has a low ground pressure, so we're able to go on SSI sites without any interference. In this picture here, this was another United Utilities job where we had a complete pipe inspection vehicle rig, a pipe inspection recovery trailer, all at the base of, forget the name now. Names are the first to go as you get over 25 apparently. So yeah, so basically that was another job. I think it might have been Vernon Aqueduct, but whatever the job is, we will either design and build the system to do it if we haven't got a system in place, and wherever it is, we will get there. And that's how to contact us. Right, that is the end of the presentation. I'm tired of my own voice. Anyone got any questions?
Excellent. Thank you very much, Paul and Glenn. I think there's some very interesting case studies in there to see. And I think from some of the comments and questions we've had, you know, I certainly would think that not every day and every project in your business is the same, is it? Because I think every project seems to have its challenges and require different types of equipment, and yeah, it's not one size fits all.
Yeah, almost every job is bespoke, different piece of equipment required. Yeah, almost every job is like that.
Yeah, so this is one of the first questions that's come in. It seems that you've designed a lot of bespoke survey equipment. Is it the case that the equipment can be reused on other projects, i.e. deconstructing the survey and used it for other projects? Because obviously I assume there's also a cost benefit if you can reuse existing equipment.
Yes, everything is designed to be reusable. Most of what we build is modular, so parts can be taken off and used for other machines. Much of the time it is only a case of modifying something that we already have, or you can modify it to be able to house LiDAR, sonar, non-destructive testing equipment. So yeah, that's pretty well where it is. So we can design and build something from new if required. We can use an existing piece of equipment if the job matches, or we can modify it to suit.
Okay, next question is actually one from me. So I think it was a 3rd or 4th case study. You showed the ROV going into a live water main, and you sort of had the launch system in there. So did you feed, was that ROV still with umbilicals? Did you feed the umbilicals through that?
Yeah.
Right.
Yeah, the ROV was dropped into a launch chamber, which was valved on either side. And when the cable then passed through a gland on the top hatch that was bolted down. As that passes through that gland, that's water sealed. So we can open the valve, and then the water main itself is back in service. So that's a completely live site with a serviceable working water main.
Okay. Next question, what pipe material is the Lido survey applicable to? I.e., does it work with some of the plastic materials?
Almost all materials, all bar, we have had some issues with not getting decent reflected light from very black materials. So there are some instances where we don't get a reflected laser that will produce us a decent model. But other than that, like I say, very black pipes, other than that, all materials pretty much.
Okay, and I suppose with that, you can do some trials, Kenny, beforehand to see whether...
We know almost straight away. From scan one, we could almost straight away tell.
What is the accuracy of the Sonar survey?
The sonar is accurate to, I think, about 10.
I think it's 5 millimeters.
Yes, so
5
depending on the...
2 meter pipe.
Okay, so I've just been... Carry on, Glenn. I've just been corrected.
Yeah, we've been working to plus or minus 5 millimeters to a 2 meter pipe. And that is a linear. So if we were working on a 4 meter asset, you'd likely to find plus or minus 10 millimeters.
Okay.
Does that make sense? Does that answer the?
I hope so. What is the accuracy of the NDT and what pipe materials? Is it working on cast or ductile iron pipes?
You mean the radar?
Yeah. So I assume with your NDT, are you actually looking at scanning for imperfections or corrosion holes? Does it pick that sort of stuff up?
On the NDT, if we're working with cast, then it has to be an eddy current system that we use because of all the slag content and the irregularities in cast iron. We do use ultrasonics for steel pipes, and we've got an ultrasonic system that will measure HDPE pipes. But predominantly, if we're doing NDT testing, we would normally opt for the eddy current system.
If you're making reference to the radar works that we carried out, the accuracy is very much dependent on what frequency head is used, and it depends what you're looking for and where you're looking for it. If you're looking at the higher, just to give you a broad outline of it, the higher the frequency, the narrower the window of survey, the lower the frequency, the further that window opens up. So that varies a bit.
Okay, next one is, are there any difficulties with retrieval of silt samples from pipelines?
Yes, we've just carried out that for Northern Irish Water through the consulting engineers. No, I've forgotten the consultant engineers, yes, but we took samples from some outfalls in Northern Ireland. I think the problem was there was very little silt in these particular ones, and it tended to be more solids of light, small particulates of ragging. So there was not a lot to pick up. But yes, we do have silt sampling technology available.
We can come back to an earlier point there, Martin. I think the exact same thing applies. It would have to be looked at on a job-by-job basis, but ultimately perfectly doable.
Yeah. Okay. Hold on a second. It's just scrolled up. What are the main difficulties experienced with PIV inspections and the main problems that WSG have experienced during surveys? So I suppose what's your biggest challenges, really?
I don't think we got time for that.
It's a lengthy list. Probably most recently is access into the assets. Small manholes, like Paul said during the presentation, trying to fit a 2-pint machine into a 1/2 pint hole. that's a common occurrence.
I think we could say that about most projects, isn't it? Our
Yeah.
biggest challenge is always getting there and access. So
Yeah.
yeah.
The things mentioned earlier, flow rates, water clarity, conditions within pipes, with outfalls is a whole different set of challenges, weather conditions, harsh working conditions. So I think it's fair to say that on a fairly routine basis, we are experiencing just about every challenge that we've discussed and you could probably think of.
How did you sterilize the equipment for the potable pipeline inspections and and convince the client that the equipment is cleaned adequately for potable water?
Okay, well, what we've done on a number of the projects, well, including for United Utilities and more recently for Thames Water on some of the potable jobs, first of all, we send a list of the component parts that the pipe inspection vehicles are made from. They're then approved by the Thames scientists or chemists for prolonged immersion in potable water. We will then scrub and jet wash the systems before they leave the unit. We then hose them all down with Chloros. They're wrapped in polythene, cling film. We then complete a form confirming that this has been done. That same cleansing process is then repeated on site in front of the client, so sprayed down with a diluted Chloros solution, and the cables are passed through a Chloros cable bath.
Okay, there's a couple more last late questions coming in. Is there any sustainable ways to dispose of silt other than landfill? I assume this is from when you've been cleaning the pipelines and you're using your vac system to remove silt. What usually happens?
It's a good question. More often than not, we'd be using a third party to deal with that sort of material. But I know from past experience, having worked in wastewater and disposal industry, a lot of the silts and grits and stones from sewers and pipes are used for capping, not necessarily sort of landfill, but for capping landfill. Not all of them, mind. They have to go through a testing process for that, but that does often happen.
Can you survey part full gravity pipes or culverts which can't be fully drained down? Sorry.
Just to finish that one, what we do find on most of the outfalls that we clean, the Environment Agency or the Scottish Environment Agency, they don't have an objection to the recovered material being spread out over the seabed, because the argument is whatever's been drawn out would have normally just washed out under normal operating conditions.
Okay.
Sorry, the next question.
Yeah, that's helpful. That's great. So yeah, the last one was about are you surveying part full gravity pipes or culverts that can't be fully drained down? So basically with your ROVs, are you doing them through a fully flooded pipe, or can you do them through partial flow?
Any of the above.
Yeah, any and all of the above. We have floating systems, submersible systems, crawlers for dry use. So on the floating systems, we have CCTV and camera below water, CCTV cameras on pan and tilts above water. In some cases, we can use LiDAR, but we have to be holding the system very steady for that to work effectively. So really anything from dry to fully surcharged pipes are what we do.
Depending on the state of the pipe, it dictates what level of service we can supply and the type of survey that we can supply though. Like in a dry pipe, for instance, there's no sonar survey and so on and so forth.
Okay, excellent. So I think that's come to the end of the questions that have been on the chat. Again, if anybody has specific inquiries or questions, they can contact you guys obviously directly at the Water Services Group. I'd just like to say thank you very much, both Paul and Glenn, for an excellent presentation. It was fascinating to see all these different pieces of equipment that you have. And I know from personal experience of working with you guys that you know, you certainly have some kit, and you like a good challenge. So
That's very kind of you to say.
We'll get that tenner in the post.
yeah, so thank you for the webinar. Just before I close, just like to remind upcoming events that are happening at the Guild, which are available on the Guild's website. But the Guild 2021 annual general meeting is taking place on December the 16th from 10 till 11. That is for members only, but please, if you can join us for the AGM, that would be greatly appreciated. On the 10th of February, we have the London Showcase lecture and the Lion's Lair. And the lecture's about women in engineering, which will be with our new Executive Director, Kate Lazenby. And also a final remember, on the 8th of March, we have the annual dinner, the 64th Annual Guild Dinner, which is taking place at the Grosvenor House. So thank you all very much for attending. This webinar will appear on the YouTube page, hopefully within the next week. And thank you very much. Kate, we can stop the recording. Thank you.